So, first of all, hello, I'm Anna. I'm working as a developer advocate for Red Hat, and I enjoy a lot to share from my experience and from my experiments with the wider community. I am a Java champion and certified architect. I love to work both with Java frameworks, but also with Kubernetes, OpenShift, and everything that is related to containers. You can find me on Twitter at Ambra1508. And the reason why we're having today's session is because I'm a bit of a control enthusiast. And so I like for things to go smoothly, and I like to think to a lot of situations when things might not go so smoothly, and like to cover those scenarios where things are not going that great. Those being said, I'd like to bring to your attention a page that probably you've seen before. In this page is one that you see that when the connection has timed out, or with the connection to a certain application is taking too long to, or too long to respond. Sometimes you see this when an application is too busy or is not available. And even if you're going through all of those bullets there, you're going to kind of realize that probably it's not your fault. Now, if you are like really, really patient in regards, seeing how an application that you're using is behaving, and you're like, it doesn't matter, I'll come back later. I trust this application. Everything's going to be fine. Well, the next question I want to ask you is, well, how do you feel when your application is too busy or not available? So the baby that you have worked with together with your colleagues is not behaving as expected in production. Yeah, we're talking about production, because in the other environments, it's like we have time to fix it. But how do you feel when your application is too busy or not available? Now, when you're seeing this, and probably your end users are seeing it as well, you're feeling some kind of a rush to fix things. And today we're going to talk about what to do in order to address that rush, and what are the options available there in the cloud native world. So let's take a closer look to resilience. What resilience means. Well, I could give you the definition, but I would rather have it a little bit more visual for you. So resilience, the way I have learned it, even in university, is the situation when an unexpected condition occurs. Your application is behaving normally, but suddenly starts not to behave that normal because unexpected events occur inside it. And it gets into a faulty behavior mode. Now, that faulty behavior mode can be detected via detection control mechanism or algorithm that you have put there for your app. Then you can have some feedback after you put that detection control mechanism to recognize the malfunction. And maybe have your application running in a degraded mode behavior. Okay, not as great as before, but still putting up something for your end users, and maybe putting up a similar reality to make the users feel that they're still using a perfectly normal application while you are working on recovering the control and to restore the expected behavior for the end users. Now, this is pretty much how probably many of you have felt about building resilient apps, like, okay, address having normal behavior, getting into a faulty one, and then have a recovery mechanism there. But if we're looking closer to the situation, we want to know what we can control. Of course, we cannot control unexpected conditions or events, right? So what we can control is actually these three items: the detection control mechanism, the feedback control mechanism, and the recovery control mechanism. So these are under our control as developers, as DevOps engineers. And those being said, where do we start? Now, where do we start, or where I started, was at application level, and that's where we're going to start also today. So at application level, if I'm probably going to ask a lot of many developer, they're going to give me some options regarding, okay, make an application resilient, and one of them is going to be circuit breaker pattern. So implementing the circuit breaker pattern in their application code. Because if, for example, something not expected is happening with a specific functionality, they can watch over that one, open the circuit, execute the fallback for that one, check from time to time if things were fixed. And if things were fixed, close the circuit again and just make the users happy again with the normal behavior of the application. But let's look a little bit into this one and into details at the application level. So thanks to Adam, he already talked a lot about Quarkus, and I'm not going to reiterate a lot on that one. But I can tell you that in my today example, I am using two Quarkus applications, and we're going to look first of all at the first one, which is called activity. Activity is consuming an information from the board API. So if you're not familiar with the board API, it exists, and it gives you information. Okay, let's try it out. About activities that you can do when you're feeling bored. This was very useful for me when in my country there was lockdown. It can give you ideas, and it can give you also what you can do if you have participants, and of course if you have some budget. It's a really useful API. Now, my activity microservice consumes information from this area. And by the way, is running on Java 17, and of course is a native. So the image that are built, the Docker images that are being built based on the container images that are being built based on my microservices are the native ones. So it's Java 17 native running, because this is a cloud native talk, right? So what I did, okay, coded this one. I just said, okay, if I want to consume it, that's easy. I just specify the URL here for consumption, and I implement an interface called activity service, where I'm defining several methods, to have to do the consumption part. And let me go to activity and say Java 17, just to make sure that it's Java 17 running. Let's say mvn Quarkus dev. And this is going to start my app, of course. And not only that's going to start my app, probably things are going to be working awesome. And everything's going to be fine. Okay, let's go here. It's not an 8080. This one starts on 8082 in my local. Let's go to dev UI, Swagger. I also put the open API on top of it. And yeah, let's go here with type. I don't know, I'm just going to say like music. Hope this type exists. And ask for some activity coming up from there. Okay, so music is existing, gave me an activity. That's great. Now let's simulate that something bad is happening. If something bad is happening, and I'm just going to add here an S, and this API doesn't exist. Quarkus is going to live reload this in the background. And if I'm executing the same query again, if I don't do something about it, this lovely exception and stack details will be propagated later in to the end users, which is not very nice. Luckily, there is a Quarkus extension called is more like fault tolerance, which I added here. So it's added in my project, and I can use this one to make my application fault tolerant, and use several annotations there, which are microprofile based. And I think Adam has talked about microprofile in his talk in the beginning. So let's go back here to my service and make this resilient. So said about circuit breaker, right? So at circuit breaker, it's an annotation that I can add and to employ the circuit breaker pattern for my app. And I can say, okay, open the circuit when 75% of the requests are failing. But try to do those requests, try to reopen the circuit and see if it's in half open and things are working fine every, 3 seconds. Next, we can see and do requests, but what can happen is that maybe those failed requests take a lot of time to come back with a failure problem to you, right? So what you can do is add a timeout annotation and specify here hey, wait for 250 milliseconds for that request to be executed, and then if something is wrong, the timeout annotation is gonna throw a timeout exception that can help in identifying that something is wrong. But in addition to this, maybe you want to retry things. So you can use a retry, and that retry will be triggered by the timeout. In the retry, you can say, hey, try at least 4 times, and between each retry, wait like a second. Maybe things will be better in in those seconds. So these are like 3 mechanisms that can help you with the part with detecting if something is wrong and getting the feedback about something getting wrong, and even stopping, the wrongness. However, your end users still deserve something, right? So this is the word that at fallback is entering in the conversation. And for the fallback, you can give a method where you can do some processing and offer the end user something, or you can have your own class. And I'm going to say default basic hobby dot class here. And I'm going to implement this one in my app. So let me implement the default basic hobby, and I'm going to create it as an inner class. So I'm going down here, and I would probably normally do the default basic hobby implementation of the fallback handler. However, I said that this is working with Java 17, right? So what I would do, I'd probably do this record, since I need to make an immutable class and I need to use it only here. So why not make it a record and have the fallback handler returning a default hobby. No, a basic hobby, sorry about this, basic hobby. So all the time when you need to return a fallback, make sure that you're returning the same return type as the method that is being annotated with that fallback, and implement its methods with the handle, of course. And here, I'm just going to say basic hobby.empty, and voila, that's it. Now let me go to my application, and let's try the music again and how things are going to work for the music. Now, my empty method returns only that participants are 0, prices are 0. Probably is not very satisfying answer for an end user. However, at least it replies something else instead of a big stack trace. I mean, not everybody can interpret stack traces, or maybe even your front-end apps that are consuming this type of service can take over such a response and understand that, hey, we need to do something else. We need to show to the end user something else. Now, if you're interested in how all these exceptions are going together, the situation is going as follows. The resilience part, I got it here in the details. So you know what's the state of going through each activity and happening for each of these, so that you would know how to use them further. So this is just for you to later inspect it, but I believe that this sequence diagram would be useful for you. Now, if we're looking a little bit upper, because we can solve resilience at the application level. However, we feel don't want to burden our microservices with having resilience in each of them. We can use the proxies in the infrastructure level to achieve infrastructure resilience. And when I'm saying infrastructure, I'm referring mostly to Kubernetes / OpenShift deployed apps. And of course, we can use, in this case, some available patterns, which are service discovery. But we can add on top of those load balancing patterns, circuit breaking, retries, and deadlines. Even in the infrastructure, we can do that. And of course, we can add load shedding. So there are a few patterns that can start with what's available on the basics of the platform, and you can build upon with several more by just adding different cloud-native technologies. First of all, if you're looking for implementing failover or fallback, you can do that with Istio, for example. You can start small, and honestly, I would recommend you to start progressively when you're implementing a resilience wherever you're doing it, like application or infrastructure. So first of all, you would implement it in the Istio, and here I just simulated for you that by deploying a gateway config, you are just intercepting the traffic. You're just then routing your traffic through the ingress controller, and based on destination rules and virtual services, you can juggle your traffic. So for example, if version 1 of your deployment is becoming unavailable, And if you're adding in the destination rule the locality load balancing setting to be enabled, you can put the failover part and have the load balancing available there, so that when V1 is not feeling well, automatically that one to be balanced to V2. Istio is very good in doing that. Moreover, you can even do circuit breaker pattern implemented with Istio. So you can do the fallback. Okay, so you know that now V2 is there for you to work. And then you can also add more about managing concurrency when situations are not going that great in terms of V1. So you can specify everything about your connection pool, how many requests should be handled, and to also look a little bit at the load part, not just like handling the failure and have a backup for that one, but have a backup also for a lot of load part. And since we talked about Istio, and my deployments are going to happen, by the way, in OpenShift, let's simulate a little bit the Istio part that I just talked to you earlier. No worries, everything will be shared with you, including my repo. So in my repo, you're going to find the instructions on how to work with everything that I will show to you today. So everything's documented. And all the examples are there with simulating load balancing and locality failover, or simulating without circuit breaker. And the without circuit breaker enabled, let me go here, clear, CD, and make this bigger. If we are to simulate this one, we need a few things. So first of all, I need the deployments to happen. And I'm just going to deploy them here. Okay. And then we're going to deploy two backends, so V2 and V1, the ones that I showed you earlier. Look at my gateway if I have it enabled there. And of course, I'm going to need the gateway URL so that I can simulate, the loads. And then I'm going to apply the destination rule. Now, this is the destination rule without anything enabled to it. So it's like without any pattern happening there. And now that I have everything done there, if I'm doing siege, which is like invoking concurrent requests to my endpoints, and I'm saying, hey, do 10 requests for concurrent users to this endpoint, and this endpoint will throw a timeout exception. Let's see what happens. So these concurrent users are accessing this endpoint that it's faulty, pretty much like in real life. The endpoint is retrieving a 504. Remember, this is no circuit breaker applied yet to the Istio part. And you can see that the requests are sometimes taking between 5 and 2 seconds. Now, in our world, 5 or 2 seconds for a request to happen, it means a lot for the end users, and probably even for yourselves when you're like working or you're like employing or working on doing some activity with a web app. It's a lot. And you can see here that the elapsed time, it's like 23 seconds. So it took 23 seconds to do this. And the longest transaction was 5 seconds. Now let's go again here to this part and apply the circuit breaker pattern. And this is the second part. So I'm just changing a bit the destination route to have the circuit breaker pattern enabled. And let's do again requests. How come it said it was not found? Oh. I have to do it in all the tabs. Now, the difference that you should follow here is that because I have the circuit breaker pattern put there, the response is no longer 504, which was the service one. It's the one that Istio is giving like 503. So that says, hey, network is 503. But each request is taking less than a second. So this is a huge improvement compared to the latest one. And the longest transaction took 4 seconds. It was only one. And the elapsed time, so meaning the total time spent on identifying failure, is 5.57 seconds, which is great when you're trying to see where the failure is, instead of like waiting for 23 seconds to find out where your problem is. And of course, if there's the failover part, then everything's going to be routed to the working one and so on. So this is the good part of having the circuit breaker pattern at the level of the infrastructure as well, together with Istio. Moreover, if you're like looking to have a different type of failover, let's say, and not employ Istio all the time, because I've heard developers or DevOps engineers saying like, yeah, it's an extra work with working with Istio, and I get it. There's probably you need to learn a few more things. The thing is that you can implement failover, for example, with Scooper. So Scooper.io is a layer 7 service interconnect. It can work across clusters. You can deploy it across clusters to like implement failover, or you can implement it across the across the namespaces. So you can do it two ways. And I have shown here in the picture how the failover mechanism is working with Scooper. So for example, if my front end is receiving a request and is forwarding that request, is trying to get it from the next backend that it has to it, which is in the DAC namespace or cluster, if that backend has an issue, it returns that to Scooper, and Scooper will try to get the same response, but from another connected area, which is in this case Benelux. If Benelux is feeling fine, it will return a response and everything will be good. And let me show you how the Scooper part is being installed. So you have in Scooper set up everything that you need to know about setting up what I've shown you there. And I've not used just 2 namespaces. In this case, I've used 4. So in the example here, front end is in Benelux together with backend, and the other backends are in C, DACH, and UKI. And the easiest thing to be done there was that I have created a token. I initialized in each of them Scooper and created a token in the first one that I want to have like the master, the head one. And the other ones that are the failover namespaces, I just use the same token to link it to the master one. And just to show you, in the Scooper console, this is how the deployments look like in all the namespaces. And they're all feeling healthy at the moment. If I'm looking at the deployments part and the graphic part, let me show here, confirm, and show the requests. Let me go to the doc route and hobby frontend. So this is my frontend, and send a request. So the first request that I'm going to send, of course, are going to be replied to me from the doc because this one is available and online. But you see here that when doc took too long to respond or it became unavailable, other requests were served from UKI or CE or Benelux. So from the other areas where the service, the backend service, is available. And if we're like looking around into the console and refresh this one, you can also see a very nice activity happening here, and see that, well, the front end indeed has sent like 4 requests to activity. But when activity didn't feel well, has delegated this one, thanks to Scooper, to Benelux or to CE or to UKI. So in the end user didn't feel that its requests were served from different places. They got the same, feeling that their response was served, even though that you behind the scene have used Scooper to get the failover response from different places. So keep in mind to have this one as available for failover. Now, last thing that I want to touch with you together today is load shedding. According to the Site Reliability Engineering book, load shedding is a technique that refers to dropping a portion of load of traffic and the server is approaching overload conditions. Now, this is a little bit extreme, like when people are seeing drop is very, everybody's like really scared. So like, oh my God, this refers to dropping. But actually load shedding is referring more to drop, prioritize, or send with low priority. So you should like send with low priority or prioritize and send it later, that request, so that you're not, in the end, not serving an end user request. How the load shedding is working? Well, there are two big options available, which are ramified in different algorithms. So one is rate limiting, one is concurrency limit. Rate limiting, I've implemented at application level with bucket for J, by the way, and you're going to find that in the repo. So this kind of algorithm is very useful when you're like trying to limit maybe at application level, but you can also do it with Istio as well. When you have an incoming request, what you're doing, you're checking if the incoming request has reached the the size of the bucket. If the size of the bucket was reached and you're like overflowing the bucket, you should prioritize send with low priority that request or drop that request. Now, if that bucket size was not yet reached, of course you're in a safe zone, you should send the request. And you need to do this algorithm like with a certain rate. So you have a refill rate for your bucket. You're checking that when you should refill the bucket so that um, is allowing more requests, and just not just having it full there, and then not serving any requests forever. And this refill rate, you can like put it and have it there at a certain duration. So if you like want to identify when should you refill the bucket again, you can calculate the duration by having the bucket size over the refill rate. So all the time you can like have a mathematical precision when implementing this algorithm, even with code. But you can also have concurrency control, the other type of load shedding, which is done with request priority. And you can do that, done it with Istio. I thought it was easier by just having the headers matching in the destination rule to a specific user agent to be redirected to the V1 microservice. This is the way that you can like choose to serve the most important requests faster, and then or give them a dedicated endpoint to be served, instead of like having everything randomly assigned and served. In the high loads time, it's good to have like a good request priority established so that you won't end up like losing end users. How about interplaying auto scaling with load shedding? Because probably some of you thought already like, hey, but if I have a lot of workload, isn't auto scaling there to help me? Why do I need to think of load shedding, which is like dropping traffic, which is bad? Isn't auto scaling enough? This question is good, it's very good. And you should like think that auto scaling is very well working with load shedding. This is why. Let's assume that you have an auto scaling condition. You know that it is going to scale your app when there's a certain CPU load. So there are requests coming to your app, and the workload is increasing. So your app is like feeling the pressure. However, if you have load shedding in place, even with the rate limiting technique at the application level, you can reduce the resource stress. And of course, this load shedding mechanism, as we spoke, is applied on certain durations, right? So if the bucket is refilled at certain durations, you reduce the stress. However, when load shedding stops, you should look at the traffic. And if the increased traffic continues, which might be a huge chance to happen, this means that you will end up probably in the same situation that you were here. However, if your load shedding has stopped and it won't kick in unless like in several seconds or minutes later, what you can do is like trigger the auto scaling condition. So that one is taking over and is spinning up a new instance for your app. And if everything is fine and the increased traffic is not going on anymore, then everything is like in the beginning and smooth and nice. So you can always think of that interplaying auto scaling with load shedding and have a great way to reduce the stress over your services. Now, technologies that I use during the demos, of course, Red Hat OpenShift and Red Hat OpenShift Service Mesh and Quarkus and Scooper. So you'll find all these in the slides here. I know that it was pretty much fast going through all of these patterns, but the slides will be shared and also the code, and you have everything explained there. And I'm welcoming feedback on the code and on the presentation. And you find more resources on what I told you today, like working with Stio, working with Kubernetes, or modernizing enterprise Java in the books written by my colleagues. So do make sure to check them out. And of course, now if we never have time for Q&A, but I can answer your questions in the chat, and the code is available on my GitHub. Do make sure to scan it. So yes, and thank you, Maria, for putting the tab polls and answer the questions in there. So I have asked you a few questions that are related to the session, and I just wanted to get your feeling about it, because a lot of people are like a team application for resilience, team infrastructure, and there's also team pipelines. So please make sure to answer the polls there, and I'm looking forward to your questions in the chat. So and hope that you'll enjoy the next session as well. Probably I should leave now. So feel free to interact with me here. I'm still available, so still present here. You can try to write in German to me, but I'll use Google Translate to translate and answer in English. But we all speak technical language, so I do assume that we'll have a very, very good conversation. Enjoy the rest of the sessions. Bye.